The only difference when we get into FOIL is going to be, well, now I've got two terms going with each part. And a lot of you are probably used to just seeing the arrows flying everywhere with these. To multiply it out, put it together, you're fine. Which is okay for a lot of people, except here's our dilemma. Sometimes you may forget where you've already drawn your arrow and what you've already done. It can get confusing. Hence, excuse me, back comes this box that I was talking about yesterday again, where you just put what's in the parentheses on each side, fill up the box, and then your terms that are alike magically just fall together and you can get the same answer. I don't care which way you use, I just like this more because it's more visual. But we're going to start a little bit with what we were doing yesterday. Now again, I'll do it both ways on this. I want you to find a way that's comfortable for you. If some of you are still comfortable going old school way, and you would just as soon use the arrow and just say, okay, 2 times 3 is 6, so that's 6x. And then 2 times -6 is -12. I don't see any like terms and I'm good. That's fine. I'm good with that. But if some of you get stuck on something like that, I want to find something that'll help you out. So we're going to look at a box here in a minute. Yep, same side. So, again, if I'm distributing, the biggest thing that people tend to have issues with when they're distributing is they always remember the first term. And then they get to the second one, they forget, and they just write +1. That 6 has to be multiplied through to each of those. And the other thing that goes along with this, kind of in our little mini review that we're doing here, is going to be, if I'm multiplying and there's variables involved, I got to add their exponents. So x times x is just going to get me x squared. So little things like that are the things that if you forget them on a quiz can ding you for lots of half points. But hopefully with this is going to help us remember it a little bit more. The other things, again, and I'm going to go box on this one. I keep talking about using the box and then I'm not doing it. So I would just write whatever's on the outside, I'd leave there. And whatever's in the parentheses, I'd just write across the top. And then I'm still going to distribute. I'm just letting the box make sure I do everything. 4 times 2, I'm still multiplying the numbers in front. It's going to be 8. X times x, I'm still going to add my exponents. Then I get over here, same thing. 4 times 7 is 28. I have an x, no more x's there. I'll just write it down. And in this case, what's in the box is what's my answer. And I'm set. Even if the value that you see you're going to multiply through comes from the other side. We get so used to seeing things a certain way that we think it always has to be that way. Well, whatever I distribute is sitting right in front every time. Not every time. Sometimes maybe it's in the back. Okay. I can multiply that number this way. 4 times 7 is 28. -3 times 7 is -21 with an x. And if one of your issues is, well, I'm not real good with the multiplying, especially when it's positive and negative numbers. Okay, use the calculator then. There's no harm in that. But it's better to do that and have an issue that we can fix than to just say, yeah, I'm not going to do anything. You know, this is whatever. That's not going to get you anywhere. All that's going to do is have you seeing more of me probably, which I don't know if any of you'd want to do that. So then we finally get to this new stuff. And again, I'm not a big fan of having arrows being drawn all over the place. It just gets confusing. So whenever I see something that's bigger like this, I'm going to make a box. And the size of my box adjusts with whatever my terms are going to be. And some of you may be wondering, well, what if I put the x plus 8 on the top and the 5x minus 6 on the side? You'll get the same answer at the end. So that's fine. And now we just multiply to fill the box. So I'm going to put my 1s here for my exponents so I remember that. So here I got, okay, so I got 5. I don't see a number over here, so I'm just going to use the 5. Multiply, I'm going to add my exponents. 1 plus 1 is 2. X times negative 6 is negative 6x. 8 times 5 is 40. Still have that x. If you want to put x to the first, you can. And then again, we're multiplying. 8 times negative 6 is negative 48. And here's why I'm a big fan of the box. The box organizes things for you in degree order even, and that's nice. Because whatever the biggest thing is going to be here in the upper left. So I got 5x squared. And then as I move through the diagonals, that's where my like terms are going to be. 40 and negative 6 is 34. And then minus 48. Degree of 2, degree of 1, degree of 0. It's in standard form for me. So that's really nice. And that'll work on all of these. That's the other thing I like about the box. Works for everything. It's not like it's just a small piece that it's going to be working with. So for instance, let's say we go up to 9. I want to keep working on the big ones here for a bit so we can get a good feel for how these work. So, again, get my ones in here. And I go ahead and multiply. 2 times 5 is 10. Add my exponents. 1 plus 1 gets me 2. Here, I'll just multiply the numbers. Negative 3, watch your sign, it matters, times 2 is negative 6. No other x's though, so I'll just put my x there. 5 times 8 is 40. And again, no other x's, so I'll just write my x. And this last one doesn't have any x's at all. It just times the numbers. Again, multiply to fill it. 8 times negative 3 is negative 24. And I start from the upper left corner, and I get everything I want. I got 10x squared. My diagonal will have the x's that I need. 40 minus 6 is 34. And then that minus 24 at the end. And I'm done. It's not like it's a terrible process. It's just remember I multiply to fill the box, and I just combine stuff that's alike. Nothing too terribly awful. So, what we're going to do next then is we're going to find some special cases that sometimes can make life a little bit easier or maybe harder depending on how we're doing it. So we're going to take a peek at a couple of these. And again, you're not going to see me probably doing anything but boxes when it's terms like this, just so I can kind of see how this works. You might find a pattern, though, that makes this go a little bit faster. We'll see. B times b, add my exponents, b to the second. B times 5 is 5b. Negative 5 times b is negative 5b. And negative times positive is a negative 25. Now here's what's special about this one. Still got a b squared, okay. But when I get to my diagonal, oh, positive 5 and negative 5, they cancel. This will be true every time that you get the same variable and constant, but you have a plus and a minus in the middle. So if everything's the same except one's plus and one's minus, you just multiply the first two, multiply the last two. You're done. It works the same way on 11, just so you see that wasn't a fluke. I'm going to multiply my values together. It may not always be the squared one that comes first. 8 times n, 8n. 8 times negative n is negative 8n. And negative n times positive n is n squared, but it's negative this time. That can happen occasionally. She's like, well, what do I do then? Because here's my biggest one now. Okay, I can still start up here though. So I've got 64. My positive and negative 8n cancel. And I get that. Now, would we like to put it in standard and put negative n squared plus 64? Maybe. Maybe we would. But it's not going to be a big deal if I forget that. And the last main one, I got 2 problems left I want to talk with you about, at least for today while we're introing this. One is, what happens if I get something that says squared on it on the outside? Does it mean I just get to distribute this and be done? No. What it means is, I have 2 of these. So if I have 2 of them, I need to do what we've been doing on all of these, and I need to actually multiply this out, because you're going to find out it's not just x squared and 9, there's another term in the middle that's going to happen. Just like I've been doing on the rest, just gets into habit. X times x is x squared, because I'm adding the exponents. X times 3 is 3x. X times 3 is 3x. And 3 times 3 is 9. Multiplying to fill the box. Once I have that box filled, though, now it's just all like terms. That's it. Nothing else. Three and 3 is 6. And I get that 9 on the end. So it's that 6x that I wouldn't get if I just distribute it. That's what I've got to concern myself with. That's what I've got to work on to make sure I don't get that messed up. Last thing. I'm going to go to the big crazy one. I'm going to go down to 16 here. I'm going to skip past a couple of them. Ooh, now I got 2 and I got 3. What's up with this? No problem. Box is expandable. Box can go to any size I need it to be, which is why it's a good tool for you to have available. I'm still going to do all my multiplying just like I have been. I'm going to put my 1 on here so I don't forget. So 3 times 3 is 9. Add my exponents. 1 plus 2 is 3. 3 times negative 2 is negative 6. And I have x's in both places, so I'll add the exponents. And then 3 times 1 is 3x. I can put the 1 on there if I want to. And then I start in the next row. 3 times 2 is 6. And then there's no other x's, so it'll just be x squared. 2 times negative 2 is negative 4x. And 2 times 1 is 2. And here, when we get into the bigger ones, here's my biggest reason for liking the box instead of just distributing everything everywhere. Biggest term up here to the left. And then every diagonal after that is going to have my other values. Well, that's kind of interesting. Negative 6 and positive 6. Okay, that won't happen every time, but it did this time. Then my x's are in the next diagonal. 3 minus 4 is negative 1x. And then my 2 is left at the end, and I'm done. So again, just be cautious. Just watch out for things, because you never know, and some little twist may come like that. Or I may do something goofy like I do down in 17, which is going to be the only one we do down here. The only time I need a box like this is if I'm multiplying. Notice there's no plus or minus in the middle. No plus or minus in the middle. Okay, it's just, oops, it's just parentheses. However, when I get down to the bottom, I might throw a couple of these in to see if you're paying attention. If you put a plus in the middle, no multiplying, just combine like terms. Not only would you do more work if you did a box on this, it'd be wrong on top of it. Who wants to do that? If it's minus in the middle, just make sure the minus distributes. The only time the box is a successful method for doing things is if it's multiplying, if there's no plus or minus in the middle of my sets of parentheses. Otherwise, I have to just do the adding or subtracting that's there and get my answer. This is part of what we're doing. We're teaching us to try and keep an eye on detail issues. Am I adding? Am I multiplying? Am I subtracting? What am I doing? And then doing it. Without practice, I don't get good at this. I keep making the same silly errors or write IDK or leave it blank. That's not doing anything for you. It's better to try it and have an issue that we can fix, because if you don't try it at all, you're never going to be successful with it. So this is kind of a preview looking ahead at what's going to be going on. We're going to start some of this tomorrow after the quiz and go from there. I just wanted to give you a little bit of a preview. Now, if we want to focus in on what you need to know tomorrow specifically, that's this other guy. And I want to work through a big chunk of these with you, just to remind you, all of those note sheets we've done on this, you can use on this. So it should make life easier on you. But in case you forget, or if you want to try it out on your own, here's what we can do. So what we're going to do, okay, write in standard form. What's that mean again? It means the biggest exponent to smallest, the greatest degree to the smallest, and name the degree. But I need to have it in standard form before I can really do that well. So my first job on all of these is to find the largest degree term and write that first, and then work my way down. So I don't see 4, but I see 3. Take the sign with it. Then I see 2, take the sign with it. And then I see 1, and that's positive. And then I see my constant. Now it's in standard form. And then the degree just comes from taking the biggest one. My degree is 5. And I'm good. Sometimes I may get fortunate and it may be almost ready to go for me already. So like if we were doing number 2, let's say. Biggest exponent. Take that negative with you though. The 7 doesn't have a negative, so that'd be positive. And my degree is just going to be my biggest exponent. And then I'm going to leave you a couple of them to do yourself too once you have that as an example, because redoing it on your own is part of the battle here. So if we move a little further down here, I'll give you some time for sure here in a minute to be able to work on some of those, but I want to practice some with you. Okay. The next section says simplify the expression, write it in standard form. Okay, well I see a plus in the middle, so it really means I don't have to worry about any of this stuff. But if I'm going to write it in standard form, I want to find the part with the biggest exponent first. Okay, which would be the 4th. So, okay, so 5x to the 4th. Let's see, thirds. Ooh, I see 2 of them. Got to watch the signs though. -6 plus 2 is -4. Notice I'm not changing any exponents. And then finally, I have 7 x's, and I have one more here. Gives me a grand total of 8. I don't see any more terms. They're in order from the greatest degree to the least, and I'm done. But here's what I've got to be cautious of. I've got to be cautious of a problem like 6. Looks simple enough. But that blasted negative is there. And that negative has to go all the way through here. Oh, nope, not here. So, I'm not changing anything in that first set of parentheses. There's no negative in front of it. I don't have to change anything. But here, I'm going to change this to a negative, change the sign on my 7a squared, and change the sign on my 6a. That's all that minus does, is it changes signs on everything. And then I go through and start putting stuff together. Now, so I'll start with the squared. Then I look ahead and I go, okay, so 6a and minus 6a. Ooh, they cancel. They're opposites. Okay, I'm not going to have any of those. 4 minus 3 is 1. And I've got it as simplified as I can, and I'm done. So that's my only real thing to watch in this section even. Do I need to get that situated? Okay. One last one. I'm going to skip down to 10 here, because I want to leave a little bit for you too. Wow, lots of sets of parentheses. But remember, there's one thing we're looking for. Is there a minus? Because if there is, everything in the parentheses right after that's going to get the negative. So I'm going to rewrite what I have in the other parentheses. I just don't make any changes. But wherever I see that negative, so 5x to the third becomes negative 5x to the third. 8 becomes negative 8. And negative x to the fourth will become positive because it changes the sign. No sign changes here with this being plus, so I'll just write those down. Lots of stuff to combine though, so I really better take my time, because if I've done all this right, it'd be a shame if I started losing points because I got sloppy. All right, here's my x to the fourths. Remember, there's a 1 in front of this one. 5 plus 1 gives me 6x to the fourth. Let's see, x to the thirds. I got negative 7 and negative 5. That's negative 12. Plus 1 is negative 11. I only see one term that has just x, so I'll write that down. And finally, I've got 3 minus 8 is negative 5, and I go in degree order all the way down. And that's all we're really kind of messing with here, is working our way through some of these to try and make this simplify down a bit. The last thing that's going to be coming on this upcoming quiz tomorrow is going to be some of the stuff we've been doing this week. Now again, when I'm multiplying through, and we did some of this at the start of the lesson, you can either distribute like this and say, okay, 5 times 8 is 40. Get my little ones here. B times B, b1 plus 1 is b squared. And then 5 times negative 4 is negative 20, and I'll put a b on it. Okay, that's fine. If you can look at it that way and it works for you, I say go for it. But if that tends to get you stuck, or you'd write 40b squared minus 4 because you forget about it. Again, just because it's not 2 sets of parentheses doesn't mean I couldn't do the box. Get my little exponents here. And again, when I'm doing the box, I'm multiplying to fill it. So 3 times 4 is 12. But then I add the exponents. That can be the tricky part. Remember my exponent rule. 3 times 7 is 21. And I put the x. And the cool thing is that one's ready to go just the way it is. They both work. I just got to make sure that I get it multiplied all the way through. All right, let me move down to equations here because I don't want to go into overkill on the multiplying since we've already seen some of that today. So I'm going to do one of each of these with you. So let's see. Let's try out 17 and 19 here. Okay, solve the equation. If I see any like terms on the same side of the equals, I'm going to do that first. So that would be 4 plus 5p. Once I combine any like terms, my job becomes solve for p. Okay. Well, right now I'm adding 4 to 5p. Well, I'm going to do the opposite. And don't think just because you get 0 on the other side that it's like no solution or that you can't solve it. Sure we can. 0 is divisible. I can divide 0 by 5. It's still 0, but it works. So it's always about opposites to get P when we're doing equations. And we're going to keep mixing all these things together just so we don't forget how to do them. $19, if you wanted to box that little part, you could, but notice nothing happens to the 8x, it's just this 8 I'm multiplying. So 8 times -2 is -16x. 8 times 4 is 32. And now I've got a problem similar to 17 now that I've done that part. I look on the same side of the equals to see what the like terms are. Okay, so I got 8, then I got -16. Think about money. If I got $8, but I owe my friend 16, I think I'm still going to be in the hole here. If I give him the 8 or her the 8, I still owe him 8. It's better than before, though. And now it's just get that x term alone. I'm plussing 32 to it. I'm going to minus 32. Showing work reinforces it for you, and it also lets you make sure you don't do something silly. Here, I'm multiplying -8 and x. That's not minus 8, it's times -8. So I got to do the opposite and divide. And I'm set. So your job is going to be to finish off these other ones we didn't do together. This is exactly what the quiz tomorrow is going to look like. It's going to be 20 questions. It's going to be the same number of questions in each section. It's just going to be, I'm going to switch some numbers and variables around a little bit. So if you can do this, you're in good shape. This will be online. I'm going to have the key online. I'm going to have extra copies of this. If you want an extra one to try out later, to take it like it's a fake quiz ahead, that's probably not a bad idea. But we'll do this tomorrow, and then we're going to work some more on foiling then.